for joining us for this afternoon's webinar. Due to COVID-19, we can't have our face-to-face interactions this year from the Australian Intercollegiate Meat Judging Association, so we've moved to a couple of digital formats. And so we've got a webinar series each month. We'll bring you some great topics across each month. So I'd just like to welcome everyone, especially our international guests as well. And I'd like to remind everyone that these webinars are not just for undergraduate or students. These are for anyone in industry. So producers, processors, tech companies right across industry. So if you've got any friends that you think would enjoy these webinars, please send them the link. You can keep up to date with what's happening through Australian ICMJ via our Facebook site, Twitter, Instagram, or if you're an alumni, jump onto the LinkedIn alumni site as well. So our upcoming events, we're getting a few podcasts together. We'll have a webinar every month. And if you are a company or a student, I think you really should think about getting along to the Virtual Careers Expo that we're holding on the 10th of July. So we've got a fantastic platform to host that Virtual Careers Expo, so you can have one-to-one interviews with students. And so if you are a company or a student, please register for that event. We're running this meeting or this webinar as a meeting, not as a webinar. So you can please use the chat function down the bottom to type in your questions. You can also chat to your colleagues that may be on here today if you like. And so you can ask questions of the group, or you can ask questions of, or you can just chat to each other. Michael's managing us, so he's got us all muted at the moment. At the end of each section, so Graham will speak first, then Will, then Graham. At the end of those three sections, we'll be opening up for questions. You can either do that verbally or via that chat function. So without further ado, I'd like to thank Graham and Will for joining us today. So I'm going to introduce them both, and then Graham will kick off for his presentation. So Graham, if you'd like to start sharing your screen, that'll be tops. So Associate Professor Graham Gardner is a professor at Murdoch University in Western Australia. And Graham's also the chief investigator for the large national project called Advanced Livestock Measurement Technologies. So this is about a 6-7 year project with lots of funding bodies you can see down the bottom there, and Graham is leading up that. And today's presentation is about one program within that, about the measurement of lean meat yield. Graham grew up in Esperance and moved and did his undergrad degree at University of Western Australia, and then did a PhD at Murdoch University, and then spent some time here at University of New England doing a postdoc, and is heavily engaged in eating quality and yield research in both beef and lamb. I'd like to also thank Will, so Will Barton, for presenting today. Will's the CEO of Gundagai Meat Processors since 2014. Prior to that, Will spent a fair bit of time in the agribusiness sector. He set up, or he was a director of the agribusiness group within CBRE, and prior to that was heavily involved in doing property valuations. Will's got a couple of degrees, a Bachelor of Associate degree in food science, first of all, when he was still working in his family business, and then later on when he was doing property valuations, did a Bachelor of Applied Science in Valuations. So thanks, gentlemen, for your time today, and I welcome your presentations.
Righto. Now, Tomo, I'm assuming you've unmuted me, so hopefully I'm all good and people can hear me. And Pete, the other thing I really have enjoyed doing over the years is supervising my PhD students. And would you believe Peter McGilchrist was actually one? So Pete's one of the ones that I'm really proud of, because he's absolutely smashing it across the industry. So on that front, I do want to talk about lean meat yield. So Pete introduced that really well. And I was thinking I'd cover a few areas. I thought I'd start with some really basic stuff, just emphasize the business proposition of lean meat yield. I was going to talk a little bit about the industry measures. I won't spend too long on those. And then I'll give you a bit of an overview of ArmTech, and then I'll dive into the detail about the DEXA system, our work in lamb, and how we're now predicting cut weights. And I'll pull up there so that Will can have a say. and then I'll come back on and talk about other lean meat yield technologies to finish with, and also talk a bit about DEXA in beef as well. So value proposition first, and of course I think everyone in this audience knows it pretty well. This is simple stuff. 2 carcasses, exactly the same weight, let's call it roughly, so they're both about 23 kilos. If one of them is fatter, its saleable meat yield will be less. So that means you can cut off less to sell from a carcass of the same weight, just because it was so fat. You had to trim all that fat off and you chuck it out. And ultimately, so in this case, it was done, and you can see the value difference between those 2 carcasses. Now, this varies, of course. It depends upon the trimming specs, and it depends upon the retail prices that you're selling those cuts for. So dream up your own trimming specs and your own retail prices, but you will find this type of differential every single time. And that's worth about 30 bucks in this case, and that varies from supply chain to supply chain. So that's the simple business proposition. If you collect that much extra at retail, it filters back through the supply chain. So it's worth big bucks. So on that basis, carcasses are traded on carcass weight, of course, because that's a big driver of how much cut weight you'll cut off them, but also on the fatness of the carcass. And these are usually applied as penalties. So in lamb, there's the GR tissue depth penalty, usually at the really fat or the really lean end of things. And in beef, they use P8 fat depth predominantly, but also rib fat depth, and you'll see that deployed within the MSA system. So I reckon we should start by just asking the simple question about how well do these existing industry measures actually work. And to illustrate this, what you're looking at here, this is lamb data. We're using on the bottom axis there, the x-axis, we're using carcass weight and GR tissue depth to predict the composition of the carcass. Now, when I say the composition of the carcass, I'm talking a pretty fancy measurement here. So this is using a CT scanner to tease apart the bone, the muscle, and the fat that's in that carcass. And you can see that image on the left of the axis there. You can see the bits of bone, and then there's bits of lean in there, and those darker bits in between are bits of fat. So the CT scanner does a really good job of teasing that apart. It gives you a really exact measurement. So that's the relationship, but have a look at the data. So this is about 3,000 lamb carcasses here that have been CT scanned, and we've used GR tissue depth to measure them. And you can see just how noisy that relationship actually is. And that's what supply chains are actually dealing with if they're measuring GR tissue depth with a knife. But most of them aren't. Most of them are actually palpating GR tissue depth. And they do it down in the lumbar region on the spinal processes. So to be honest, it's even worse than that. And in beef, the situation's not much better. At least in most cases in beef, they do measure it with a caliper. So that's the P8 site in this case, predicting, in this case, this is the rib fat site coupled with carcass weight, predicting the CT composition of the carcass. And it's again, a pretty noisy measurement. So this illustrates the real drive to establish this ARMTech project, which is called the Advanced Livestock Measurement Technologies Project. So our job is to try and take better measurements. So these are the value transactions that occur right from conception all the way through to consumption of the animal. And our job is to try and insert measurements that better quantify what's in the animal, both in terms of its quantity, which you can measure as lean meat yield, and also in terms of its eating quality, which you can measure using a range of different devices, and the beef MSA system does a very good job of this. So we've got a focus both in the abattoir, so we're trying to develop carcass measurements for lean meat yield, and I'll be focused on those today. But we're also focused in the live animal, trying to develop carcass measurements in the live animal as well. And of course, the eating quality measurements, they are heavily focused in the abattoir. So there's a range of different devices that we need to come up with. We're looking to try and commercialise 5 lamb DEXA systems and 1 beef DEXA system within abattoirs by the end of our ARMTech project. So we've got another 2 years. We're also working with the pig industry, so we're trying to commercialise a similar lean meat yield system called PorkScan in the pork industry. And also we're looking to commercialise a few eating quality type cameras. So these are the sort of cameras that will measure intramuscular fat, for example, in beef and in lamb. And Pete actually talked about some of those in the last webinar, so you would have seen him in action there. Now, I actually reckon that, that ICMJ has got a lot of synergies with all of this, because I do know the focus of this group is all about quantifying what's in the carcass, both in terms of the amount of cuts and also their quality. So in effect, I reckon there's really good parallels with the ICMJ system and with Armtech. So just turning back to our agenda, just to remind you where we're up to. So we've looked at the value of lean meat yield, and we've also talked about existing industry measures and why I think that they don't work very well. I've given you a quick look at the Armtech an overview of Armtech. So let's now have a look at the lamb DEXA system. So this was originally developed. It sort of kicked off back in about 2012. Scott Automation and Robotics, who are a New Zealand-based company, had a robot that was cutting lamb carcasses into 3 parts. So they were basically dissecting off the forequarter, the saddle, and then the hind section. And you can see in this photo here the cuts that robot was making. And that Xray image that you can see there was driving that robot. So the question was, could we adapt that Xray image to try and work out the composition of that carcass? And in effect, that's what the early work was all focused around. It was focused around adapting a 2D Xray image to convert it into a DEXA image, which stands for Dual Energy X-ray Absorptiometry. So we inserted one of those systems in at JBS Bordertown, and then we scanned the lambs that you can see here. Now, the key thing when you try and train a system to predict something is you need a big phenotypic range, a big diversity of animals that you're actually scanning. And here you can see we had a thumping big range in carcass weights, so sort of 11 kilos all the way through to 40 kilos, and a big range in GR tissue depths across that. So this was quite a challenging flock to try and predict, but the DEXA system did a very good job of it. And you can see the sort of precision just visually that this system has achieved. Now, just to remind you what the alternative system looks like is that GR tissue depth prediction of the same trait. So it's that, and then here's DEXA by comparison. So it's ultimately going to be quite a big step forward for industry once we get this system deployed. Will talk about the work deploying it at Gundagai. We've got it deployed in 2 abattoirs for JBS, so that's Brooklyn and Bordertown. And there are another 2 abattoirs that are installing the system right now. So one at Frews in Stawell, and also Wamco in Katanning in WA. So I anticipate that by the end of this year, fingers crossed, there'll be 5 systems installed across Australia. Now, we've done a little bit more work just to demonstrate the robustness of this system. One of the things you do want to know is that if you took the same carcass to 2 different abattoirs, you've got to get the same answer. And what you're looking at here is a group of 30 lamb carcasses that have been scanned at Bordertown, and then they've also been scanned at Brooklyn. So this is the JBS abattoirs, and they've been great supporters of this project. And you can see the alignment in those scans that we got between those 2 sites. Now, obviously, there would be a bit of carcass dehydration, which we can never really escape. And that would add a little bit to the noise that you can see in this data. But ultimately, those values, for all intents and purposes, are really well aligned between those 2 sites. So it gives you good confidence. The other thing you also want to know is that if you scan a set of carcasses, can you get the same answer many times in a row? Now, we did this 5 times in a row, really rapid fire, and yeah, we got pretty much the same answer then, but this really pushed the system a bit more. So we grabbed here, you can see, this is a mate of mine by the name of Steve Connaughton. He's gone and grabbed a group of carcasses and he scanned them on Monday and then he scanned them on Tuesday morning and Tuesday arvo, Wednesday morning and Wednesday arvo, and then he did them again on Thursday morning. And you can see that effectively he's got that really good alignment, that really good prediction of CT fat percentage right across the week. So it's a system that's got really good repeatability and really good robustness over time. So that's a bit of a high-level overview of the LAM DEXA system. I thought I'd just finish up before I pass over to Will, just talking about the cut weights that this system can also predict. So when we first did this work and trained the DEXA system, we CT scanned these carcasses, and that's the trait that we're predicting when we talk about composition. But we also boned them out. And this bone out was really detailed. So we ended up weighing about 160 different bits off each of these carcasses. There were 200 carcasses in total that we boned out. And so we've been able to train the DEXA system to predict these cut weights. And just to give you a bit of a look at a couple of them, very simplistically, here's the round and here is the short loin. I like these two cuts. The round's got very smooth seams, so you can peel that one out. And the short loin, there's a fair bit of room for human error in the short loin because you've got to trim that cap down to 6 mils. Now, the boners were really concentrating, so they were trying to do a really good job to minimise that human error. But you can see in both cases, we've been able to predict the weight of those cuts really quite well. Now, I can take this one step further. So this is getting into a little bit of micro detail now, but I thought it might interest you. Those previous predictions, they're based on the composition of a carcass, and it's the whole carcass image, the one that you can see there on the left. But we know that the Scott's cutter can chop that carcass into 3 bits. And there's an algorithm which tells us where those cutting lines are. So what we did was we used that algorithm to dissect that image into the 3 bits. And then we said, well, would the prediction of any of these cuts be better if we actually focused on that part of the image that the cut has come from? So for example, let's go and predict the short loin using the saddle section of this image. And that's what we did. Now, there's a bit of reason for thinking that this might have an impact, and that's because of the effect of genetics. So we know that eye muscle depth breeding values redistribute that muscle tissue around the carcass. And in fact, across a 7-unit range of those breeding values, you'll actually find that the lean in that saddle region is 5% heavier in a carcass of the same weight. So that's quite a big effect. And if you don't have a regional calculation, you'll never pick it up. And we found that with the cut weights. So here's the eye of the short loin. Of course, as carcass weight increases, the short loin increases. That's not exactly rocket science. But the 2 red lines there, they show our ability to differentiate the weight of that cut using the fat measure. So in this case, it's GR tissue depth. And so down at the light end, you can see that using GR, we can see an additional 10 grams difference in short loin weight. And then up at the heavy end, we can see 31 grams difference. But if we use DEXA, and this is the whole carcass imaging system, all of a sudden we can see 49 grams difference extra in short loin weight. And that's in a 13 kilo carcass. And then in a 40 kilo carcass, you can see about 145 grams. But if we go to that regional information, then all of a sudden it really starts to open up. And in the heavy carcasses, we can see about 240 grams. And in the 13 kilo carcasses, we can see about 80 grams of extra short loin weight using that DEXA measure. So that, of course, has value. And if I just crudely multiply those by 24 bucks a kilo, which is one retail value, you can sort of see the value of that difference in weight that you can actually see before you've cut this carcass up. So knowing that value, it starts to give supply chains the ability to make decisions about how to cut those carcasses up. And I'd say this is exactly what Will start talking about next. Among other things, and that's the ability to measure those carcasses in great detail, both their weight and their DEXA composition measurements, and then estimate their cut weights. Knowing their retail values, you can then start to work out how best to cut up those carcasses to meet the market demands that you've got access to. And if you can optimize how you target those carcasses for the different markets that are out there based on those measurements, you can optimize the amount of money you make. And one of the leaders in this space is actually GMP. So at this point, I'd like to pass over to Will to pick up from here and tell a bit about the GMP story.
Thanks, Graham.
Graham, and while Will's just setting up his share screen there, has anyone got any questions for Graham up to now? If you've got, you can either type it in or you can unmute yourself and ask it verbally as well. So there's one there from Low Hoffman. Graham, do you see the ability to predict specific cuts will be of value for smaller processing plants?
I actually think that one of the real business cases around having the DEXA is to also drive automation. So I do actually have to concede up front that the smaller processing plants that don't have automation in are probably not likely to go for this system. The other crucial thing that you need if you want to estimate what your cut weights are and make use of that information is carcass tracking through your chillers. And most of the smaller plants don't have carcass tracking either. And in fact, many plants in Australia don't. One of the ones that does is Gundagai, and it's what gives Gundagai the capacity to act on this information, and it's part of what makes them leaders in this space. So, so yeah, for the smaller players at this point in time, it's going to be a journey, and the step in will, I think, early on be tricky. It's not impossible though.
All right, if there's no further questions, then we'll pass over to Will.
Thanks, Peter. I think we need to be able to pull Graham up because he'll make me blush if he keeps talking about how good we are.
Trying to give you a plug, mate.
Yeah, thanks.
You revved up from the start.
Thanks for having me first, Peter, and the ICMJ team, and Graham for the lead in. I suppose the focus of today is really around DEXA and our experience with the commercial install and rollout of DEXA. But in terms of what I'll present, that's really a small part of the whole piece for us. So DEXA is just one technology of 4, which I want to go through in a little bit of detail, that we have on plant, which we hope will change the industry quite significantly. And then I want to take the viewers through, I suppose, what will be, depending on your view about how quickly it happens, an evolution of lamb, or as I would much rather it be, a revolution in lamb. So just to start with our commercial experience, our rollout experience, we started this in mid-2016. So we're 4 years in the making. These things don't happen overnight. They take a fair bit of effort, and I think it's worth just revisiting that fact. And it does take an extremely large amount of commitment from a business, because over those 4 years, there's probably at least 10 occasions where GMP could have chosen to not pursue this. So that's a big part of, I suppose, the conviction that you need if you're going to pursue this kind of innovation and technology. The project cost totals just under $2.5 million, and about 900,000 of that has been funded by the MLA. So again, a massive investment for GMP in R&D, because, well, hot side, which I'll talk about in a second, this isn't yet proven from a couple of angles. So the other thing I just wanted to touch on in terms of our commercial install and rollout is the challenges we've had. So you can see in the graph on the bottom right-hand side that our scan rate in the 18 weeks that this tech has been fully operational with the latest algorithm ranges on a weekly basis from 40% success to 100% success. And so this is not the success of the machine when it scans a carcass. It's got 99.9% success when it's scanning a carcass. This is more around whether or not our system is putting a lamb carcass through the actual system. So, for example, we're the first, what I call hot side DEXA, or the first DEXA that's been placed in the world on a slaughter floor. Slaughter floors have got heat and steam and a range of other things that you don't have in the boning rooms where JBS has their 2 DEXA machines. And so we have a carcass wash that's right next door, and it likes to trip the light curtains that safeguard people from walking into the Xray room. So that invariably has an impact on how often you're able to put lambs through. If there's an issue with the light curtains that are being tripped by a carcass wash, then ultimately that often leads to the system being bypassed. The other thing is that as slaughter floors become more and more automated and more robotics are used, you have a range of production software and automation software that's handing over and handing back between systems, synchronizing chains. And so passing information to and from DEXA, simple things like passing hot standard carcass weight to the DEXA algorithm in real time to inform the algorithm to make the best prediction, become things that are really, on the face of it, quite simple to solve, become quite challenging. And so because DEXA is not something that's required to execute the slaughter floor's daily duties, which is to turn a live lamb into a meat carcass, there's an internal challenge that you have around meeting your production requirements and at the same time getting this technology up and running. So it's certainly something that's improving. The red line's running in the right direction, but there are challenges when you install this kind of kit. I just want to jump in now to the 4 key innovation and tech components at GMP, and before I do that, I just want to recap the why. So we see as a business and as a processor that we have a really well-defined and critical role in the supply chain. We need to get the product to flow from producer to consumer, and we're a critical step in that path. And equally, we need the feedback from the consumer to get back to the producer in terms of what to breed, what to grow, and what attributes they're looking for. So a big part of our why as a business is our role in this supply chain. And it's really the context we give ourselves when we think about all these pieces of tech. I think the other thing for people that perhaps haven't been in industry for very long or starting out or don't have a really good understanding of the lamb market and its differences to beef are that the current weight-based thinking is all that lamb has. So lamb is inherently by definition up to about a year old, and the only quality measure we use on site really is weight and at a very high level fat score condition. So typically the way a livestock or a lamb population looks is something like the graph below. There are very few 10 kilo carcass weight carcasses and very few 40 kilo carcass weight carcasses, and then in the middle of that range there's the proliferation of carcasses that we would call trade lambs. And typically at an abattoir, the light end gets exported to the Middle East as a bagged carcass. The middle gets traded domestically as a carcass into butcher shops or retail cuts into supermarkets, and then the heavier end of the scale is put into retail cuts. And so there's no quality grading in industry at present. It's simply and no real consideration for what the yield outcome is of those heavier lambs, other than we know that when they're very fat, they cost us a lot of money in trim. So that's the context that we've got now. DEXA, as Graham's alluded to, measures lean meat yield, fat and bone percentages. A low yielding carcass on the left might look something like the image there with only 40% meat, and a high yielding carcass might look like something on the right at about 63%. Health for wealth is the second piece of, I suppose, innovation and tech that we're using on site, and it monitors 20 significant animal health conditions across lamb species. The critical element to this project is that we're converting what is currently mob-based estimates of different animal health conditions or defects in a carcass to individual feedback by carcass. So you'll be able to take this information, and I've got a few examples of how it might look, some fictional examples of how it might look in the future, and get an understanding of whether, say, arthritis is driving yield loss or weight loss in your population when you bring it to slaughter. The third element is intramuscular fat, and I think this was covered really well in webinar number 1. And we know it has a really important role in understanding eating quality in lamb. Obviously, now that we're able to accurately forecast or predict the lean meat yield of a carcass, the second and really critical element is to understand the intramuscular fat. We know that countries like New Zealand, who have had Viascan tech, which has been able to predict lean meat yield for over a decade or two, has meant that payment systems, yield-based payment systems, have moved their flock average IMF down to something just under 2%, and we know that Australia is somewhere around the 4% mark. So we need to be really mindful before we take DEXA and use it, from a producer feedback and from a pricing point of view, that we have IMF covered. And this really becomes why it's so critical to have intramuscular fat measure, and it's so critical to have all these ingredients as a single package, which I'll take you through in a few slides' time. So we know that if we can understand intramuscular fat, we can grade out premium carcasses and cuts, and we know that if we can give farmers feedback on intramuscular fat, then they can improve their genetics, improve the quality of their livestock, so that they can in time get paid more for those animals. So the fourth piece, which really brings this together, is the concept of carcass optimization. So if you can imagine what we've been through today, we now have lean meat yield at high accuracy. We've got Health for Wealth, which will be launched in the next month here at GMP, which will give individual insights into which carcasses and their corresponding weight and lean meat yield have certain animal health conditions or carcass defects. And we're waiting for IMF. And what that data-rich environment creates is the requirement for two critical ingredients to be able to turn that information into some sort of meaningful success as a business. So the first one is intelligence. You need the right tools to be able to interpret this data and to tell you what to do with this data. So ArmTech and the Sheep CRC's development of the carcass optimization tool is sort of a cornerstone of this, and the work that they've done to be able to say, well, if you understand all of these attributes about a carcass, this is a tool that can help you sort, which was what Graham was referring to in his presentation. The other thing you need is somebody internally who has the mental capacity, the intelligence, to be able to digest this and get it back into real world. So for us, that's Dr. Michelle Henry, who is leading our charge in terms of being able to use this data-rich environment to our advantage. The second thing that you need is infrastructure. So it's all well and good to have all the answers about all the carcasses, but the ability then to actually execute on turning that information into actionable results throughout the plant requires infrastructure. So GMP has invested a large amount of money over the last 3 years in an advanced carcass chilling and sortation system, which I'll take you through quickly for context. And it's the combination of those two things, the understanding what to do with the data that you've got, and then being able to action that intelligence throughout your plant, gives you an increase in value across the entire supply chain. And to Graham's point, it allows you to pay farmers in a targeted fashion for the quality and the yield that they're producing. It allows you to command more from your consumers because they understand what they're getting and there are guarantees around it. So to run you through carcass optimization quickly at GMP, the before situation here, we've got 7 chillers. They all have hot lambs loaded into them immediately post slaughter. You have no time to gather information about a population. As each lamb comes down, you must make a decision about whether it's heavy or light based on parameters you set before production. You have to keep hot and cold carcasses separately, so you've got to fill a chiller at a time and then close the door and move to the next one. And you've got quite a labour-intensive system where you're manually transferring carcasses more or less with your shoulder and pushing them along, and you don't really have any individual carcass tracking system beyond a tag, a printed tag. What we've done at GMP is convert the same space into 5 chillers, where the chiller on the bottom of the page is where every single carcass passes through and stage 1 chilling occurs. Chiller 2 conducts stage 2 chilling, and then 3, 4 and 5 are all sortation chillers. And what that does for us is it moves the sortation point to 2100 lambs post-slaughter. And by then, lambs are at about 10 degrees Celsius. So before we have to make our first sortation decision about any of the lambs that we've slaughtered, we know population level data. We've got 2100 lambs worth of information from that production run. And so by maximizing that time between data capture and sortation, we're able to sort from the best informed viewpoint. It overcomes the hot and cold carcass mixing issues, because every carcass that leaves the stage 1 and 2 chilling is down to about 10 degrees. So we can hang them next to a carcass that's processed at 2 o'clock in the afternoon can be hung next to one that's been processed at 6 a.m. that morning without risk of them raising the carcass temperatures. And it's 100% no-touch automated and RFID tracked. So those 4 technologies combined is really what comes together to create real advantage in the supply chain. Any one of those in isolation doesn't really dramatically change the landscape from our view. That really leads into then what is what you could refer to as an evolution or a revolution, depending on what your thoughts are around it, and the start point, which is fat score and weight distribution. So I'm going to take you through about an 8-slide pack here, which walks through what we think the evolution will look like. This data set is a data set of about 1,000 lambs. They're mixed sex, crossbred lambs. Their weight range is sort of circa 15 to 40 kgs, hot standard carcass weight, which is a good wide range. And as you can see here, there's a tendency for the fatter lambs to be heavier and the leaner lambs to be lighter. And that's what we've had for the last 40 years, weight and fat score. What we have now that we have DEXA is a circumstance where the same carcass data can be presented, but instead of having fat score, we can have lean meat yield. So you can see that trend in a much more granular fashion, which shows hot standard carcass weight on the y-axis and lean meat yield on the x-axis. And you can see again that as a lamb gets fatter, it gets heavier. If we were to then add defect and disease data, and we've generated 3 fictional defects and disease in this circumstance. The first one, which is yellow, doesn't appear to be correlated with hot standard carcass weight or lean meat yield. It's sort of evenly distributed throughout the population. The second one would appear to be more prevalent in low carcass weight animals, and we don't know whether that's the cause or the effect of the disease or defect. And then in example 3, we can see that that particular example is more prevalent in higher, leaner carcasses, so higher lean meat yield carcasses. And again, we don't know whether that's the cause or the effect. But the ability to understand lean meat yield at a granular level and be able to report on animal health or disease and defect data at a carcass level will give rise to this kind of insights into what's happening in a population. So then if we move on and we assume for a second that we've got an intramuscular fat measure on plant, that one of these many technologies that was spoken about in webinar number 1 comes off, then we can change this population and look at it from an IMF versus lean meat yield. And you can see, as those of you that have spent any time in this space understand, that there's an inverse relationship between lean meat yield and intramuscular fat. So a carcass that's leaner is likely to have a lower intramuscular fat content, and a carcass that's fatter is likely to have a higher intramuscular fat content. If we then fast forward and graph this in a different kind of way, we can see this graph adds weight as the third dimension, and you can see that not only have you got this dynamic where as intramuscular fat increases, lean meat yield decreases, but the larger dots represent heavier carcass weights and the smaller dots represent lower carcass weights. So we can see lean carcasses with low IMF are also lighter. Heavy carcasses with high IMF are typically much fatter. And so there's no surprises in that data set, but the ability to be able to converse with a producer in this way and give signals about what they're producing and where we want them to move is the critical piece. We can then go one step further, and we will, with the addition of disease and defect data. So now you've got 4 elements that are at play here. You have lean meat yield, intramuscular fat as your 2 axes. You've got the size of the dot representing the weight of the carcass, and then you've got animal health overlaid. So we can see now that, perhaps unsurprisingly, disease and defect number 1 is still evenly distributed throughout the population, but disease and defect number 2, which was more prevalent across the lighter lambs, is only impacted by weight because its distribution is even, and its distribution from an IMF and lean meat yield it doesn't seem to be correlated with either of the two. And red, the third example, is still correlated with lean meat yield. So then the final point that you get to is that if you go back to that paradigm, the current weight-based thinking that we have, where a light lamb goes to the Middle East, a trade lamb goes to Australian domestic, and a heavy lamb goes to export, you now generate a new part of the market by bringing all these pieces of data together to say, if you can deliver something that's greater than 60% in lean meat yield and over 5% in intramuscular fat as 2 arbitrary points, then we'll pay you a premium for that product on the basis that we're able to achieve a greater price in the market. That's it for me, gang. That's the quickest run through I can do on something that I could talk to for probably 3 or 4 hours if you gave me the chance. I'll let Graham take back over and deal with any questions.
Thanks, Will, and some great messaging there, mate. So if anyone's got any questions, please type them in or just unmute yourself, and verbally we'll take maybe 1 or 2 now and then some more at the end. So there's one there just come in from Reese. These technologies obviously have great economic carcass quality and meat yield benefits for processors in the long run, but currently has significant R&D and infrastructure implementation costs. How long is it expected for these processors to see a return on investment, and what is the expected lifespan of the technology before needing to be replaced, particularly due to being exposed to harsh chilling environments?
I think in terms of the question about the harsh exposed environments, etc., tech like DEXA is much more likely to be technically obsolescent before it's functionally obsolescent. So it's much more likely that something better will come along before we wear out a DEXA unit. They're very well protected. They sit behind, cool room panel and lead line rooms. And so there's not a lot of wear in those sorts of technologies. I think at the other end of the scale, for an IMF measure, most of the things that give you an IMF result are sort of some kind of handheld probe or scanner or light kind of device, and they're a bit more of a consumable in terms of you might turn them over every year, but they're not the most costly element. The costly element is the guts and gizzards of something that perhaps sits in a box. So I think really the great challenge now is for industry to think through the impact of we know we can pay. I know that something that yields over 60% is worth about $1.60 a kilo more to me than something that's got a lean meat yield of 52, and something less than 52% is going to cost me about 30 cents. Our industry hasn't dealt with that today because we average. So we assume that we're going to get some good ones, some bad ones, some in the middle, and it'll all average itself out. So the real question, it's the same typically with concepts like IMF, but the challenge really for us now is to say, well, how do we actually ease our way into value-based marketing, and how do we make sure that we have the patience to wait for IMF measure to arrive before we start tinkering with lean meat yield, perhaps at the expense of eating quality.
And one last question, Will. Is the amount of lead used an issue around the idea of a green technology or products?
I have no idea, Pete. I think, I don't know. I have no idea how to answer that question. It's not something we've considered. It's certainly, the lead that they use is certainly a stable product. It's very well encased and it's not exposed to the environment. I know it weighs a hell of a lot, but it's more or less captured on site. And I think too, probably the other angle is that you can't chuck it out. So it obviously goes on a register along with your Xray. You register it. So if you ever decommissioned it, you know that there are channels that you have to dispose of it appropriately rather than just chuck it in the skip.
Yeah. And one last question from Terry Sim. Will, when will you be at the stage of using this data to give direction to lamb suppliers?
So I would hope within the next, I've said this a lot and there's been a lot of delays. I'd hope that in the next month or two, we'll be at a stage where we can give a scatter graph to a supplier with hot standard carcass weight, lean meat yield, and disease and defect data. And then the intramuscular fat thing is obviously the focus of a lot of effort at the moment, and that's really up to the R&D guides to deliver us something that's appropriate. Obviously, we do lots of different trials with people, and we'd hope that that's sooner rather than later. But I think what we know now, we can give you hot standard carcass weight, lean meat yield, and defect and disease data on an individual carcass basis. And I think really for the moment, producers have to rely on genetics and genetic selection as their own safeguard for intramuscular fat, such that when a measure comes for intramuscular fat, they know that they've been selecting the right genetics to make sure they're on the right side of this revolution that I talk about.
Right, we've got a few other questions that we'll just hold to the end. We'll get Graham through some content. So Graham's going to cover other technologies they've been using to look at now. So thanks, Will, and we'll come back to you for more questions. Graham.
Thanks, Pete. So I'll just returning back to my my signposted agenda here. I'm up to point 6 now, so that's the other lean meat yield technology. So I'll talk about beef DEXA. I'll talk a little bit about surface imaging technologies, and I'll just very quickly touch on fat depth prediction technologies as well. I'm going to keep this pretty light, so I'll go easy on the data. And I actually loved Will's graph. He showed that relationship between lean meat yield and intramuscular fat, and it really just brings home that crucial point that whilst we're making great advances in being able to measure lean meat yield, if we send too strong a signal to industry, and if we don't have the corresponding eating quality measurement in place, we can really stuff up the product. So I reckon Will made a great point there. So just keep that front and centre as you listen to all this exciting lean meat yield stuff. Now, one of the key points of logic here, and I've already started touching on it, is that we've trained DEXA on the CT carcass composition. So this is measuring carcass composition with a very fancy medical CT scanner. And we're using that as our gold standard trait. But you've got to ask the question, what happens when we suddenly start bringing in all these other lean meat yield measuring devices, like a 3D imaging system, or the old ViScan, for example, that's a lean meat yield measurer, or even a fat depth system. We need the same consistent gold standard trait that all these devices are trained upon, so that they're all speaking the same language. And that's exactly what we've been doing. So we've been using CT as our gold standard trait. DEXA predicts it, but so does the 3D imaging system. There's even a bit of work with ViScan to retrain those old units, and also our simple tissue depth devices are being trained on it as well. In turn, we can then predict cut weights based on the CT composition of a carcass. And what this means is that if you're a technology producer that doesn't want to do detailed bone outs, then in principle, you could get away with avoiding that so long as you had trained your device on CT, knowing that that cut weight conversion was already in place. So in some ways, it makes it easier to step in for these new technology providers that don't then need to do these detailed cutouts. So that's the first point in the logic. And I guess the other point in the logic is that using CT as our gold standard measure, we can actually communicate back through the supply chain. So using DEXA, for example, which predicts CT, we can provide feedback back to the farmers and even back to geneticists based on carcass composition. And in fact, that's exactly what we've already been doing. So there are lean meat yield measurement breeding values that are actually CT composition, and they're already in place. There's also in livestock data links, so that's MLA's system of providing abattoir information back to producers. there's a lean meat yield trait within livestock data link, and that is actually CT composition. So you don't actually have to call it CT composition of a carcass. You just call it bone, muscle and fat percentage. But in all cases, it's measured using our gold standard trait. And then if you look in the other direction, if you look forward through to retail, so if you look down this end of the chain, then from DEXA, you talk in terms of cut weights. So you convert your lean meat yield measurement into the equivalent commercial cut weights that the supply chain then wants to trade upon. So it's quite crucial that we have this language right and that we have it consistent going up and down the supply chain. So that's just a little bit of background. I'll now tell you about the other lean meat yield measurement technologies that we're working on, and you'll see the logic of why we're ultimately training them on CT. So I'll talk a bit about beef DEXA. I'll start there. I'll then cover the 3D imaging technologies that we've been working on, and then I'll just touch on a very simple device. The last one is a microwave fat depth measuring technology. So that'll be the last one to cover off on before I pull up. So starting with beef DEXA, and this work, it's been a really good collaboration between Armtech, Scott Automation and Robotics, JBS, and most recently, it's really been Tees that have been doing the heavy lifting, having actually installed the first commercial prototype DEXA in their abattoir up at Rockhampton. Now, the very early work we did was just to demonstrate that this concept would work, and we effectively designed the same type of device as is used in lamb and scanned the carcasses that you can see here. And straight up, you can see that they had a pretty good weight range and a fairly good fat range within those weights. So it's quite a diverse population of carcasses that we had a go at predicting. And this is how it performed. So here you can see the predicted composition for lean, fat, and for bone. And so these were for those 50 beef carcasses. So this is a population of 50. Now this is early days, so we haven't done the detailed work on this system that we've done in lamb. You know, it takes quite a big data set, and it takes improved analytical methods, which we're well advanced in producing. But these are the early results that came out, and they looked quite promising. So they certainly gave us well and truly enough confidence to charge ahead. Now, since then, we've had the first commercial prototype system installed at Rockhampton, and a mate of mine by the name of Ina Calnan has actually been really driving this work at Rockhampton. And here you can see that this was just evidence of the ability of this system to produce the same answer over time. So what you're looking at are 20 beef carcasses, and they've been scanned about 5 times over a 60-hour period. And if you have a look, you can sort of see up the top left here, that's the first carcass, and pretty much all sitting on top of it are the same carcass scan. So there's 5 carcass scans all sitting under that point right there. So that just shows you that the repeatability of this system is really good. And if you're excited about your statistics, then the standard deviation of those scans is about 0.17 CT lean percentage units in this case. So it's differentiating carcass composition in the commercial prototype really well, and it's doing so incredibly consistently. So we're effectively getting the same answer every time. So that's the beef DEXA system. I'll move now to the surface imaging technologies, and there's 3 that we're exploring in collaboration with various companies. One's the Frontmatic VCC3. So this is in the top picture here. You can see it's basically a series of pillars that have got lights in it and cameras. And those cameras image the carcass as it passes between those pillars, so that you can build up a 3-dimensional image. So that's a product that's it's marketed by a Danish company called Frontmatic, And we're just working with one supply chain in Australia to install the first prototype of that system to get a feel for how it works. Tees have been working with an E+V carcass scanning system, and historically Viascan have also had a whole carcass scanning system. Down the bottom photo there you can see the lamb imaging system that was developed about 20 years ago. And it was used routinely in about 3 lamb abattoirs across Australia, up until around about 2012, I think, was when the last one got pulled out of WAMCO. So there is a bit of history around these surface imaging technologies, but the newer systems providing more complex 3-dimensional images are starting to look quite promising. Now within ArmTech, we've got a group with the University of Technology Sydney that's led by Alan Pijevich, and they collaborate with New South Wales DPI, and they've actually had a go at developing their own 3D imaging system. So you can see the sort of rig here that they have designed. There's one for beef and also one for lamb. So far it's been most successful in beef carcasses, and here you can see a visual of the type of precision that they've been able to achieve so far for estimating lean percent in a carcass. And they're also just moving towards trying to reconstruct 3-dimensional images and particularly construct the cuts that would be derived from the region of the carcass that they've imaged. So here you can see the 3D image and potential dissection of a beef carcass, and similarly in lamb. So this has got a fair way to go to actually start to quantify and drive automation. But it's the beginning of a journey. All right, so that's the 3D imaging one, and then lastly is the fat depth measurement system. And so here, this is just a very simple handheld unit. It actually emits microwave, so it creates a standing microwave wave, which it then measures its reflectance from tissue boundaries. So using this, you can actually measure fat depth reasonably well. And here you can see it's being deployed. The top photo is imaging or scanning in lamb carcasses, and the bottom photo is scanning in beef carcasses. And just to give you a bit of a feel for the early precision of this device, you can see that bottom graph there. That's the early data predicting P8 fat depth in a group of beef carcasses. So it's a bit noisier. It's a very simple device. It only measures at a single site, of course. It's a bit noisier than the DEXA system, but because it's so simple, it's also cheaper and more portable. And so I think particularly for a small processor, there's potentially advantages there as a simple step-in device. Not everyone wants to go and buy a DEXA, so if you're after something simpler, this could be a way to go. We're also having a go in live animals, so measuring tissue depth and carcass composition in live animals. Here you can see we're measuring sheep, and the corresponding trait is a DEXA, a medical DEXA scan of the body composition of that sheep. So this was actually done in collaboration with Andrew Thompson's group over in WA, and you can see that graph demonstrates that measuring the fat depth gives you an adequate association with body composition in live animals as well. We started work similarly in beef too, so there's a live animal system for beef, and it's showing a bit of potential at this early point in time. So, Pete, I think I'll pull up here on the technologies. I just wanted to give you a bit of a feel for some of them. And before I pull the pin, I just wanted to re-emphasise one crucial thing about lean meat yield, and it's associated with the genetics of the national flock in this case. It's not such a big issue in beef because we've got MSA to provide the corresponding signal, but in lamb it's a big issue because right now we're not measuring eating quality in lamb. So what you can see here is traits like carcass weight and lean meat yield, and so they're the light blue and the yellow lines. They've been tracking up over time. And you can also see traits like intramuscular fat tracking downwards, and also you'll see the overall liking estimate tracking downwards there as well. So that's a consumer estimate of overall liking. Now, these are genetic trends in the lamb plan database. So this is effectively the sires that the industry is using. So you can see that we are actively making really good genetic progress in the flock on carcass weight and lean meat yield at the expense of eating quality. So this just brings me back to that point that Will made earlier, and that is that it's crucial that we get the two signals out there simultaneously, the lean meat yield measuring signal and the eating quality measuring signal, so that the industry can respond to those and, well, effectively not turn lamb or beef into pork. So I think the other thing I'd like to also just highlight is the potential for jobs in data. So you've seen how all of these devices are taking a whole array of measurements within the supply chains. I've talked about lean meat yield measurements. In your first webinar, Pete talked about eating quality measurements, and Will even touched on the health type measurements that they're also taking. Now that is creating a wealth of data flow. So within ArmTech, one of our other jobs is to help industry use that data. So, you know, we're creating new breeding values and new genetic tools from the measurement devices that we're developing. We're also trying to improve feedback systems out into industry, and we're also trying to enhance the existing MSA systems that are already out there for beef and lamb. So, and you've seen how Will is working on profit optimization systems within his plan. So they are all data-rich systems, and I think it's only going to accelerate. So, you know, if you were thinking of future career paths and jobs in the livestock industries, I reckon this is going to be a really exciting and a really rich area to get into, and a great area for graduates to target. So, so Pete, in conclusion, I've provided a bit of detail on the lamb DEXA system. I touched very briefly on beef DEXA and also the surface imaging technologies, and a very simple tissue depth device as well with that microwave system at the end. So I think I'll pull up there and take any other questions from the crowd.
Yeah, thanks, Graham. And we might just go back while people are typing in some. Terry Sim had one earlier after you finished before saying, oh no, after Will finished, the carcass cut info will it be made available to breeders to use in ram selection? Now, I guess one thing is you've been helping us out kill the resource flock lambs there. So that's the MLA resource flock. They've been going through GMP. So we've done 3 kills now this year during COVID, and GMP has been fantastic to facilitate that. Michelle Henry's done an amazing job. So that DEXA data and the yield data coming out of that for all these genotypically, phenotypically defined animals will be going directly back into the ASBVs for those animals. So yeah, that's a very
so Pete, on that question, so Terry alluded directly to cut weights. Ultimately, cut weight does put the dollar value on what meat is worth in the carcass. It also helps you understand how much meat is worth in the fore, the saddle, and the hind section of the carcass. So the DEXA system can determine how much meat is in the fore, saddle, and hind section. And right now, you know, we've got a bit of a discussion with sheep genetics going on via Daniel Brown to work out whether the lean meat yield breeding value should actually transition into a breeding value that reflects the weight of meat in the fore and the saddle and the hind as differential regions. In effect, giving breeders, if they want, the tools to target meat into those regions of the carcass that are worth the most. So that's a work in progress, and ultimately the dollar driver of that will be linked to cuts.
Follow-up question on that, Graham and Will, from Terry Sim. How is the need for technology implementation to turn around these genetic trends that we see in lamb so we can retain and improve eating quality in the annual lamb turn-off? We got before it will be too late to turn the EQ bus around?
I would say that there is never such a thing as being too late. And indeed, in those livestock industries where, you know, they have progressed to a very lean phenotype and stuffed up intramuscular fat, they can recover with selection pressure to right the wrong. I guess for us, it's more about not going there in the first place. So sheep genetics are actually doing a fairly good job of that. They're offering indexes out to industry that are balancing growth and lean meat yield, but also eating quality. So they're balancing those well. So the genetic tools are there right now, and the really switched on breeders are already using those balanced tools, anticipating that the ARMTech team go and deliver all these U-Butte measurement technologies for both lean meat yield and eating quality so that they can get paid for it. So the tools are there, industry is starting to respond, but in truth, I do acknowledge we need the price signals in place to really push industry to respond properly.
Question for Will from Paul Gibson. Is IMF the eating quality input to exercise?
Sorry, what was that?
I guess in your graphs you were just presenting IMF as the only EQ input, but you've got animal health stuff, and so there's more things. Of course, yield affects it, eating quality.
I think that it's by far and away the most profound single measure of eating quality, for sure. I think there are other things that we've managed historically. Like lamb's managed incredibly well using age and weight and basic breeding for a long time. I think probably just to add to Graham's comments around turning the bus around, I think perhaps what's a bit more disturbing for me is the height that lamb prices have got to and the demand for the product. And so what you've got when you look at that last slide of lamb genetic trends is this counterintuitive situation where the lamb price is following caviar, but becoming like a chicken breast. So you've got a chicken breast being incredibly high in protein with all the flavour and all the fat bred out of it, and it's pitched as the highly productive protein which is sold at a low price. And then you've got a kind of a confused lamb category that's on one hand developing itself to be more efficient in production, higher lean meat yield, higher weights, but still trying to hang on to this price premium for a product which has really got different attributes. So it's probably, that's something that I'm constantly fascinated by in terms of the market dynamic, and at what point how that paradigm changes as we try to turn the bus around, if you like, and what impact that has on pricing. And I think to Graham's point, those people that are switched onto this have been on this for a while, and there'll be a lot of people that instantly benefit by us measuring these things, because 5 or 10 or 20 years of theorising will be proven right, and there'll be some other people that find themselves in a position where they're proven wrong because the attributes that they're breeding don't exist. So I think that's why I think it's probably going to be more towards a revolution than an evolution, because I think very quickly once this tech's in play, we'll see big changes in the attitudes of genetics and markets and values around this product.
And just to add one more, Pete, just to add one more number to that question. So it was sort of targeting, is IMF the be-all and end-all of eating quality in lamb? Are there other traits that we should also be measuring? The truth is, yes, there are other things that impact on eating quality in lamb, but Will nailed it. IMF is the biggest one that we can measure at the moment. And it looks like it accounts for around about 30% of the variation in eating quality. So in the data that we've got, it's a monster. Bigger than in beef. It's intriguing.
Double the size.
More variation than it does in beef.
Another question for you, Will, from Rob McLaughlin. How does Australia compare to other countries in commercial uptake of these technologies?
That's a really good question, and one I've actually been looking at just recently in terms of some other activity I've got in terms of labour advisory and automation and what have you. I think in terms of lamb, we're pretty well out in front. Scale becomes a really big issue, and I saw a question about small plants we're often characterised as the biggest small plant and the smallest big plant, and we're not in either category really soundly. And I think that for us, it's been certainly something. Most of our competitors who are bigger than us are able to use this technology on a scale basis. We're sort of being forced to try to deal with it more from a quality angle, if you like. I think globally, we obviously look to places like Europe in pork, who have been doing, an outstanding job and have had a lot of this tech in for much longer than we have. But I think I don't really know how we compare globally. I do know that it's going to take somebody in the industry to challenge this weight-based paradigm in lamb, which relies on averaging, because it's really not. It's hard. It's easier to work on averages in many respects. So I wouldn't characterize it as lazy, but it's established. It's established from a producer who's trying to produce an average article, not averages in bad, but a representative article, for a processor that's trying to get a representative supply, and then for a consumer who just wants something that represents the average Australian lamb product. And so there's a big challenge when you start to say, well, let's do it a bit differently, and let's actually focus on some different elements, because a lot of people are, or the whole industry, I should say, is structured around being able to set a midpoint in a grid and then average their way out of it. So I think that's probably our biggest challenge in terms of uptake speed, is how quickly people are willing to change gears and actually allow ourselves to follow the beef path.
One final question. Do you feel the terms hogget and mutton adequately define those categories, and what did the sheep industry do about them?
Pass. In terms of adequately defining, yes. Whether hogget's a sexy enough word for the article, probably no. But people will be arguing about that long after I'm gone. So I'll just stick to my knitting.
My take on that is that eating quality is a continuum across age. The older they get, the worse they get. And a defined line in the sand is one way of reflecting that as a threshold. But I reckon we can do better. I reckon if we rolled out an MSA system equivalent to that used in beef in the lamb industry, we'd be in business. We could, the industry is not going to do away with those categories anytime soon, but we could actually characterise the eating quality of what's in those carcasses as a continuum, and then let supply chains underpin brands using that information with far better precision.
Yeah, I'd agree.
Even in the lamb category, there's a huge amount of variation.
I'd agree with you on that, Graham, and I'd probably add that, without being too flippant about it, that when we, and it really ties into Graham's comment about the career paths for people that can deal with data or want to use a good agricultural basis and combine it with data analytics and other things. If we ever look at a new technology these days that can predict things, there's a huge amount of machine learning that needs to take place to hone, I suppose, the technology. So against the gold standard. So you've got a tool that predicts something, and you're constantly going and checking it against the gold standard to see how accurate it is and all those sorts of things. I think one of the things that we're doing now, that we're getting better at doing, is when we go to the gold standard, and you'd know this too, Pete, is that you look for other things. So you say, I wonder one day in 5 years we'll realise that we can age lamb to within 10 days by, assessing the relationship between 4 data points that we've been collecting for a long period of time, when you get advanced machine learning to give you those insights. So I know we have conversations here when we're doing machine learning trials that we say, well, let's just get as much information as we can, which is the nucleus point, flock point, so that one day that one of these probes we might set out to solve for intramuscular fat, but it might predict long chain fatty acids or omega-3 or age or some other element. And I think that will just continue over time as we get better and better insights into the data that we're gathering in this data-rich environment that we have.
All right, just for our reporting back to our funding bodies, which are AMPC and MLA. We need to run a small poll, so a poll might have popped up on your screen. This just gives us an insight into how you enjoyed today's webinar. I'd like to remind you all, if you've got some topics that you would like us to cover about the whole value chain, we'd be happy to cover those for you, so you can get in touch with us via our website or email or Facebook or whatever platform you use to do that. While you're filling out the survey, I'd just really like to thank Graham Gardner and Will Barton for their time and effort today in putting their presentations together. I felt that was really amazing talking to you, and you gave us an update on where we're at with that, and Will, a very frank portrayal of the difficulty in getting these to work in the commercial space, which, you know, is really good for us to keep our feet on the ground sometimes, and for everyone to be able to see into your business is great. So thanks for allowing us to do that. Graham, thanks for charging ahead on leading ArmTech and for your time today as well in presenting all of this. Excellent. So if you do have any further ones, and don't forget, if you need to register for the Careers Expo, that's on the 10th of July, and there'll be professional development sessions for students within that, and then the an interview or meeting period for that. Is there any further questions or anything of Graham or Will? This survey data is not attributed to your name either. Zoom's smarter than that, so none of your details come across with those answers. So you can be realistic in those. If there's no further questions, thank you very much, everyone, for your time in attending today. It's fantastic to have you all along, and remember, our next topics will probably cover off on something about breeding for either yield or eating quality using genetics. So we'll either have sheep genetics in here or someone on the beef side to cover off on how we can do this on farm and the information coming into those systems to allow us to do that. If you've got any other topics, please send them through and we can sort those out. All right. Thank you very much, everyone. Appreciate it.
Thanks all. Thanks, Pete.
Thanks, Will. Thanks, Graham.